putting this into my hands. I will place a link to his website, so if you want to go and have a look at pricing and what have you, then certainly you can go and do that. In this exercise, what we're going to do a few capacitor measurements with it and a few resistor measurements and do a comparison against my Fluke 8646A with a set of Kelvin clips, and then compare measurements on my Agilent oscilloscope. Now what this will also highlight, and again that's why I've kind of taken so much time to get to the point where I can do confident reviews of these meters, is that in particular when we start doing the measurements on the scope, as noted when I was trying to do the measurement of that really low value capacitor, that picofarad capacitor, there potentially, once you start getting down to levels like that, there are loads of things which can influence a result and a reading. There can be capacitance in the probes of the actual oscilloscopes, and it's noted on the front of my scope that there's at least 11 picofarad in the probes themselves. So besides capacitance, inductance and stray resistance, which can affect measurements. So that's why it can be a real challenge measuring those things. It's why I want to have a good precision LCR meter on the bench. It'll be a good test because a good precision LCR meter apparently can go down to the low picofarad measurements and do it accurately. But at least by having the scope and the function generator, I now have a few points of reference to try and weigh up how accurate things are, and then to, as I said, to try and get some good reference capacitors. Capacitors generally have a tolerance of anywhere between 5, 10 or greater %. Their capacitance is going to vary under various conditions: environmental, temperature, humidity, and in particular the frequency that they're used at. So there are a whole lot of variables which need to be accounted for. But anyway, let's just quickly have a quick look at this and see how it compares to what the scope shows on this, and obviously in resistance measurements. Right, so the UT612 does come in this nice case, hard kind of plastic case to protect it. It does come with the set of surface mount tweezers, so that if you've got surface mount capacitors and what have you, then you can use these for your testing. It's obviously got some software because it's got a USB connection. You can obviously log data and what have you to the actual PC itself, and the USB cable. It's got this device in here, so you can obviously either use the probes inside the unit like that, or you can have this plugged in and simply plug in your resistors and capacitors in here, which is really nice because you've got a shorter lead and thus less chance of either voltage drops or capacitance in the leads themselves. So this is a nice way to actually put the devices in and take measurements. It then does come with a manual, which of course, unfortunately, again with Unity, the manuals are not the best in terms of the kind of translation from Chinese. It's okay, but not the best. This meter in particular, once you start looking at it, I'll just note some of the key features, that it's obviously measures up to about 20,000 count on the main display, and it's got a secondary display as well. It tests at 100 Hertz, 120, 1 kilohertz, 10 kilohertz, and 100 kilohertz. Now for the testing here, just so that we don't run too long, I'm going to do most of the testing probably either the low end 100 Hertz or 1 kilohertz. And 1 kilohertz tends to be the main standard, or one of the reference frequencies that a lot of capacitive testing is done at. Now again, if you want to understand a lot of the terms in terms of the different measurement modes, you can measure capacitors in equivalent series or equivalent parallel circuits. You've then got obviously equivalent series resistance, you've got your loss factor, quality factor, phase location, and I talk about all these in the first review I did of Frankie's Mustang LCR meter. So certainly if you want to get a kind of layman's interpretation of that and understanding, then again I'll link to that video and you can go and watch that just to get the first part of the video, just to get an understanding. So I say this is the guide, and then in here it quotes, it does have a sorting feature, which when I do the full review, as noted with the Mustang meter as well, you can kind of set parameters, and if you're doing a project and you want capacitors which are, let's say, within 5% of their rated capacity, you can set that tolerance and then pass the capacitors through the meter and get a pass or fail whether they meet that criteria. So a nice, quick, easy sorting facility. And it does that. And again, in the full review, I'll actually show that facility. Another thing I just want to highlight is that on meters like these, and again, it does do inductors. I don't have any inductors here yet. My kit is about to arrive, so I will have that soon. But on this, in terms of the accuracy, it is quoting for the most part, and I'll just note, anywhere between, on the kind of lower values, of 2% plus 5 counts down to 0.5% plus 5 counts. Now on the top end meters, you're looking at either 0.1% or 0.05% or around that area, and that's the kind of region, the kind of accuracy figures that I'm after to try and get a good reference in terms of this testing. As you can see, a lot of these meters, as noted, they don't go down to very low measurements. This one, I believe, let's just check. Right, so this one, in terms of the kind of range and precision, noted here, you can see the inductance values from 20 millihenries to 2000 henries, capacitors 200 picofarad to 20 millifarad. Now, I was obviously trying to measure a capacitor way lower than that, and as I said, you kind of now realize and respect the challenges with measuring those low capacitance values. And again, the high-end meters apparently do. So that's one thing I'm intrigued to see, is how well those high-end meters fare in that kind of area. And in terms of resistance, from 20 ohms to 200 mega ohms. So let's power it on and have a quick look. Right then, so we have the meter, and literally the power on button is this kind of orangey yellow button over here. It powers up, and by default it goes to the kind of default test mode of 1 kilohertz for testing devices. It can obviously test devices at a frequency, or it can do a DC test, for instance, on resistors as well. All you need to do is take your device under test, let's say your capacitor. Now this happens to be a 0.22 microfarad capacitor, and you simply slip it in here, and it will auto detect whether it is a capacitor, an inductor, or a resistor for the most part. Sometimes when the values are a bit tricky, you can then go into this function button will switch between the different modes, so you can go and select. And depending on the value, as noted, I talk about when I reviewed the Mustec, it will decide whether it's going to do a series equivalent or parallel equivalent measurement of that device under test. So as you can see here, it's come up very quickly and noted the value in nanofarad. So as I said, if you move the comma 3 places to the left, we're then going to get to microfarad, and that would come fairly close to its rating of 0.22 microfarad. And then on your secondary display, it defaults to the loss factor, which is a D, and you can switch between your Q, or your quality factor, your equivalent series resistance, your ESR, which is probably one of the more important, well, I say one of the more important ones. It depends on your application, but certainly what I'm going to highlight when I start putting the scope on is how that can play a part when you're doing measurements and understanding how a capacitor can affect a circuit. So the ESR, very handy, it's got it there. And then obviously your theta, your phase angle of the capacitor. So let's go through, we'll start off by doing a measurement of some resistors and comparing them against the Fluke. Right, so some fun camera angles again. Hopefully everything will be clear enough to kind of note what's going on. This Unity, I've got it lying down here, and I kind of, as I was setting up for the shot, realized that it's quite handy to see the kind of angle is quite low on the standing bale. It doesn't feel the most secure on that standing bale, it has to be said. These are things I will pick up in the full review, but for this little camera exercise it kind of works fine because you can see, compare the values on the 2 meters themselves. Just as a note, these are priced anywhere between $140 and about $180 depending on where you find them. As I said, down below I will place a link. If you want to support my sponsor, then by all means go to tester.co.uk, but that's kind of the price range you'll find it on. Right, so the first resistor value I'm going to check, and I'm not going to check, we're going to check 3. I don't want to check really high values because they're not going to really give us an idea on accuracy. So this is a 33k resistor over here. Now, as I said, I've got the Kelvin clips, I've got my fluke set up for 4-wire measurement, and if I place that in there and remove my fingers, you will see on the fluke in the background there that it's showing 32.96. Let's see what the UT comes up with. Right, so I've gone and placed it in here, and I, through my changing the kind of modes on here, went out of the normal automatic mode. So I'm going to put it back in there, and as you can see it's come up with 32.98. So certainly can't complain about that reading. Very close to what my fluke is doing, and as I said, because you got it right there, you negate a lot of the potential losses you get with having leads because of the losses in leads with that little device in there. Let's go for something a little smaller. Right, I've now got a 390 ohm resistor, and if we have a look at the back, you can see it's actually measuring 0.387, so 0.387k. So let's see how close that is on the Unity. And here we go. Down, I think it was a 7 on the fluke down here. So again, and there we go, it's just twitched up to that. So in terms of its resistance measurement, it certainly seems to be doing a very good job. Right, and to really test its metal, I've got a 1.8 ohm resistor. So I mean, I know my fluke is going to go probably down to quite a few places when measuring this. So there we go. So it's showing 1.79. We'll take 1.791, and here we go. It certainly is a few counts out at this level, but it's a very low resistance value, so I'm sure certainly within its stated accuracy it's still there because of the value that we add. Let's pop over onto the capacitors and see how well it does there. Right then, so before we hop over to the capacitors, something I want to highlight that caught me out that I wasn't checking. I was checking it was automatically checking the resistors at a frequency. Now for the most part you saw they certainly weren't far off what the fluke was doing, but the fluke's doing a DC test on them, it's not supplying an AC signal. So for this last capacitor, the 1.11 that's noted at 1.8, I switched over to DC resistance test, and as you can see it's come up with a far better value. So certainly again, that's something to note. You want to be aware of the type of signal that you're feeding your device under test, because obviously the results will vary, and I was caught by that. But there you go, certainly a good result for what it's measuring there. Certainly doesn't have quite the resolution, but nonetheless at kind of this level, not too bad. Right here, so